The curvature of a vector function. Before we talk about this, we first need to know what is a vector function. A vector function is a curve that is traced out by the tip of a vector. For example, let me draw a graph of this. Let's say this vector is RT. So the tip of RT traces out the whole curve. And this is the vector function. So how can we represent the curvature of a vector function? Well, the formula of it is a little bit weird. It is like this. But don't worry about it, I will prove it to you. So how can we describe this weird formula? Well, first, we also need to find out the tangent vector of the vector function. That is r prime t. In vector function, r prime t shows the change in RT. And we also need another variable that describes the change in r prime t. So at this time, this variable is the derivative of r prime t, or the second derivative of RT, that is r2 prime t. R2 prime t is the vector that makes r prime t to rotate. So to show their relationship clearer, I will draw another graph. So let's say these vectors are r prime t on a vector function rt. And r prime t is something that makes r prime t to rotate, like this. If r prime t is perpendicular to r2 prime t, the r2 prime t won't change the length of r prime t, but it will make r prime t to rotate, like this. However, if r2 prime t isn't perpendicular to r prime t, it will not only change the length of r prime t, and it will also change the direction of r prime t. So how can we describe the change in angle between r prime t and r2 prime t? Well, we can use the cross product. The magnitude of the cross product is the area of the parallelogram formed by these two vectors. So it is like this one. And this area is the magnitude of their cross product. If there is a change in this angle, there will be a change in the area of this parallelogram. So since curvature, since only the direction of r prime t will affect the curvature. So we don't need to care too much about their lengths. To make it clearer, I will change r prime t and r2 prime t into the unit vectors. So the unit vector of r prime t is this one. And the unit vector of r2 prime t is this one. And we take the cross product of them. So finally, we get this one. And this is quite similar to the part of K, to the part of T prime T and K. Which shows the change in the direction. And then we also need to derive r prime t, which shows a change in the arc length with respect to time. So finally, we can get the curvature of a vector function, and it is written in this way.